Okay, so now looking at part C, let's just go back to the question again. And it says for when x is in between 0 and pi, and y is greater than 0. Okay, so those are two important things. It says find the coordinates of the point where the line tangent to the curve is horizontal. Okay, so when are you going to have a horizontal line? What is the slope going to be? Well, for horizontal lines, the slope is 0, right? So if it wants to know at what point are you going to have a horizontal tangent line, we need to first figure out at what point the slope is going to be 0, right? So how am I going to figure out when the slope is 0? Well, using calculus, the slope of the tangent line at that point is the derivative at that point. So if I find when the derivative is 0, then I'm going to find when the slope of the tangent line is 0. Okay, so what I'm going to do is take my derivative, right? This is my derivative, and I'm just going to set it equal to 0. Okay, to find the points, the coordinates for the point where the line tangent is horizontal. Okay, so that's my first step. So we're going to say that dy dx is equal to y cosine of x over 4y minus sine of x is equal to 0. Okay, so I want to set that equal to 0. And now when is this rational function going to be 0? Well, when the top is equal to 0, right? So y cosine of x is equal to 0. And when the bottom is not equal to 0, right? Okay, so when is that expression going to be 0? Well, when the top is equal to 0 and the bottom's not equal to 0, right? Because remember, for fractions, we know a fraction's 0 when the numerator is 0, right? Like 0 divided by 5 equals 0. 0 divided by 4 equals 0. However, you just don't want it to run into that case where you have, 0 divided by 0 or 5 divided by 0, because that 0 in the denominator is a problem for us. Okay. So now we need to figure out when y cosine of x is equal to 0. So note here that you would say, well, that happens when y equals 0 or cosine of x equals 0. But note, we said in the beginning that y must be greater than 0. That was just a condition that we had in the beginning, right? For x in between 0 and pi and y greater than 0. So this can't happen. So y can't be 0 for what we're looking at, right? And so at what value is cosine of x going to be 0 in between 0 and pi going back to the unit circle? Well, that's going to happen at pi over 2. So x is equal to pi over 2. Okay, so what we've done so far has earned you 2 points. Okay, the first point was just setting dy dx equal to 0, because that was showing your understanding that to find the point where the line tangent to the curve is horizontal is when the slope of the tangent line is 0. And what is the slope of the tangent line? It's the derivative. So that earned you a point. Then actually solving for the x value now earns you the other point. Now we need to now solve for the y value, find the y value. Okay. So to find y, value, plug in x value into original curve. And solve for y. Okay, so going back to the original curve. Okay, so not dy dx. Going all the way back to the original curve. Here's our original curve right here. And so I'm just going to plug in x equals pi over 2 and for x, but I'm still going to have everything on the left-hand side, right? So I'm going to still have 2y squared minus 6 equals, and then I'm going to have y sine of pi over 2. Okay. And so sine of pi over 2 is 1, right? So I have 2y squared minus 6 equals y. Oops, sorry. Okay. And so now I need to subtract y from both sides. So I have that this is 2y squared minus y minus 6 equals 0. And so now I need to do group factoring. Okay, because if I try to factor out a greatest common factor, the greatest common factor is 1. And the problem is that I have a number in front of the y squared. So I need to multiply 2. Oops. I need to multiply 2 times negative 6, because this is my a value in front of the y squared. My c value is negative 6. So we call this the AC method, because I'm going to multiply them together to get negative 12. And now I'm trying to think of factors of negative 12 that's going to add up to negative 1, because that's the number in front of y. So thinking about this, I should come up with, let's see, negative 6 and 2, negative 4 and 3, negative 3 and 4, negative 2 and 6, negative 1, 12, 12, and 1. And so this one should work. Okay. So now what we're going to do is expand out the terms. So I get 2y squared minus 4y plus 3y minus 6 equals 0. And now I'm going to group the first two terms together and the last two terms together. And then I'm going to factor out the GCF. So I'm going to factor out the GCF of the first set of parentheses, which is 2y. And this is y minus 2 plus 3y minus 2 equals 0. So factor out the GCF between each set of parentheses. The second set, the GCF was 3, so that's why I factored out a positive 3, so that's why it became plus 3. Now I need to factor out the GCF between these two terms, which is y minus 2. So I factor out y minus 2 times 2y plus 3 equals 0. And so now I get that y is equal to 2 or negative 3/2. However, remember, y is greater than 0, so y is equal to 2. Okay, so that's my y value right here. Oh, sorry, I didn't mean to switch that. So we know that the line tangent to the curve is horizontal at the point pi over 2, 2. Okay, and so if you do need to recall back how to factor a quadratic where the number in front of the x squared, or in this case the y squared, is bigger than 1 and the GCF is 1. All right, just remember you need to multiply a and c values Okay, and find factors that add up to the b value to expand and group factor. Okay, and then when I say a, b, and c values, I'm talking about ax squared plus bx plus c. Okay, so whatever number's in front of the x squared is the a value, the number in front of x is the b value, the number after the x is the c value. Okay, so in this case, the a value is 2, the b value is -1, and the c value is -6. So that's why I was listing out my factors for -12, and the one that added up to -1 is -4 and 3. So I could then expand out -y to be -4y plus 3y, and then from there use group factoring where I factor out the greatest common factor from both sets of parentheses, and then lastly factor out the greatest common factor between these two terms, which is y minus 2. And so that's how we factor